So the talk is about managing cloud services, and we will also have a look at continuous integration solutions which are possible on Azure. Little word about myself. I've been playing around with Azure since quite some years. I think I was in 2008, 2009 one of the first people that got bitten by the Azure virus and started playing around with it. I worked for Ordina as a competence leader in the cloud service department. Not really that big, but I was entitled as competence leader, but that's not important. Then I met Martin and Chris, and we sit together during a weekend in Mons, if I remember correct. And we had the idea to found Azure, which is still alive and kicking. I'm not really part of it anymore, but I was there when it all started. I also was an MVP for a couple of years. I lost my MVP title because I joined Microsoft. And if you join Microsoft, then you obviously lose your MVP status. I worked for Microsoft for 3 years, and then I decided to step out again for a simple reason. Microsoft wanted me to become more a sales guy instead of a technical guy, and that was not really my ambition. I wanted to stay more technical and maybe try to avoid some sales talk, but that was not what Microsoft really wanted, so we stepped out of each other. I'm still a trainer. I divide my time now as a freelance consultant, so I work on my own. Started up a company called Nuboid. In this company, there's only one-man shop. It's only me. I'm not planning on growing, just for supporting myself. I'm doing freelance Azure consultancy. Not 100% of my time, but I also take some time to deliver trainings on .NET, trainings on Azure. And on top of that, I'm also building my own product together with some other guys, mobile application in the healthcare sector in Belgium. So in this talk, we're going to talk about Azure Cloud Services, how to monitor and manage them. We will talk a lot about APIs and the way that we can programmatically monitor and manage all the stuff that we have put into Azure. I'm going to show you some demos that I prepared, hope they work. We're going also to see Visual Studio Online, where we can deploy our code and an automatically build will start, which will be deployed to Azure all magically behind the scenes. So I will show you this. First of all, I want to discuss how platform as a service works. So everything I'm going to tell in the next hour is not really applicable to infrastructure as a service, because it's a completely different game, infrastructure as a service. It's only about platform as a service, the real platform cloud services, where it all started for Azure. Infrastructure as a service only came later, a couple of years later. Microsoft also decided to go into the infrastructure as a service way, but this is about platform as a service. So how does it work? We as the developer / architect, we love Visual Studio, we work in Visual Studio. We have this Azure SDK, Azure emulator, and what we do is we build apps. We build an application, could be an MVC application, WCF service, Silverlight stuff, whatever. That app is then surrounded with some configuration, really typical Azure configuration, and that the configuration tells the system about web roles and worker roles and how many instances of each do we have, and what is the size of the instances, and what are the endpoints, do we have secure endpoints or internal endpoints. Really typical platform as a service configuration. Next step we do is we put the app into the cloud by just uploading it. Visual Studio can support that. We can do that through PowerShell. There are many different ways to upload our application to the cloud. What Microsoft then does, or what the Azure Data Center does, it surrounds your application with a virtual machine. So this is the first time we're confronted with a virtual machine as a developer. We only put our app into the cloud, and Microsoft puts a virtual machine around it, or maybe multiple virtual machines, depending on the configuration. That virtual machine is then called a cloud service, or the combination of all those virtual machines. We call them cloud services. They have endpoints, the load balanced endpoint. So whenever you hit the URL, you automatically load balance. The traffic is divided over multiple machines, of course. But then we need some additional services, like a SQL database. Our application always needs a database. Maybe we need storage. That storage could be deployed also through CDN. Some applications will need service bus. A lot of applications will need the Active Directory service of Azure, media services, HDN side, and so on. So what you typically see here is, so I hope you get this message, all those services like storage and service bus are not part of that cloud service. They are just floating around your cloud service. You can even use all those services without having a cloud service. Or you can have a cloud service without having all those services around it. So they're really separated from each other. That also influences the way we manage them. So who is this? M&M. Little very not funny joke. It's monitoring and managing. I'm not really a funny guy, so I try to be, but that's the best I can do, sorry. Why? Why do we want to monitor and manage applications? Well, we got a lot of reasons. We want to know about the health of our services. Are the services still up? What about the performance? Do we need to take some actions? Or can we save costs by running only a limited number of instances? On Azure, you can decide on the number of instances, but every instance costs money. Maybe we can limit the number of instances with the result saving money, saving on operational costs. Database capacity could also be a reason why we want to monitor our environment, and we don't want to have a database that suddenly freezes because it's running out of space. That could be happening. What are bottlenecks? Do we have some bad query that is behaving very unperformant if reaching the database? Idle connections, maybe some connections are still open and we want to take some actions. What about queues? A typical Azure application will be working on an architecture where a queue is always involved to have communication, asynchronous communication between web roles and worker roles. Are messages stuck into the queue? Would also be a reason why we want to monitor something. And the reason we want to manage is, for instance, deploying and redeploying and swapping between staging and production. We want to scale the number of instances, but we also want to create stuff. Create storage accounts, create service bus endpoints, whatever. Databases we want to backup and restore. Okay, there is some functionality in the management portal to do a backup and restore, but we rather want to do it more automated through our own code, through our own applications, part of our CI cycle. What do we want to monitor and manage? Here you see the cloud service again, a very big box where inside we have a number of web roles. We could have a number of worker roles. Every web role and every worker role has its own set of instances, which are the virtual machines. Web roles have endpoints. We can have multiple endpoints for the complete cloud service. For each web role can have one endpoint, of course. We have some internal endpoints for communication between web role and worker role. Or if we want to do it asynchronously, we were going to work with queues. Queues are part of storage, which are living outside the cloud service. Also tables are there. We have a SQL database. We all want to monitor that. We want to monitor what is the use bandwidth, what is the uptime of our instance. We want to monitor the CPU utilization of our instance. Are we running against 99% of the capacity? Well, we need to take some actions. On the storage level, we want to cover volume. We want to see how much data are we storing. And also connections and queries. Transactional cost is also important. Managing is doing stuff. We want to redeploy, deploy stuff. We want to scale the number of instances. We want to backup and restore our databases. We want to create things on storage. So then again, what APIs do we have? So we know what to do, we know why we want to achieve such a thing. What APIs are there? Well, maybe it's historical, but during the lifetime of Azure, since a couple of years, Microsoft released a couple of different APIs. for different purposes at different times. One of them is the Service Management API. First of all, before we have the Service Management API, there was still already a REST API, but Microsoft also decided to put an SDK, a library, a .NET library on top of that. For the SQL database, the APIs are really old-fashioned. They are working with SQL commands. It is just executing a command like a query. Another API we have is Windows Azure Diagnostics. That could result in creating CPU performance checks and downloading all that metrics. Every metric that is available on the operating system is also available in the Windows Azure Diagnostics environment. A couple of years later, Microsoft has released the Azure Storage Analytics, which is more like a point of view of auditing your storage. It's not really about looking at performance, but really auditing your storage, who has added records to the table, what time, how many, and so on. Another type of API is working with the Cloud Queue. Cloud Queue is part of the Azure storage environment. There is one very important property which is called approximate message count that will always give us the number of messages that are in a certain queue. And another API is the load balancer probe. A load balancer probe is, well, I'm going to explain it later, is just to check whether your applications are still responding. Some attention points using the APIs. Like I said, well, some APIs are based on REST. Some are based on TSQL. For some of them there is an SDK, a .NET library. For some of them there isn't. Where do we get the bits? Well, sometimes Microsoft is delivering the bits as part of the SDK. For others, we have to go to NuGet to download some additional stuff. Authorization of the API, of using the API, well, we see two ways of working. One way is to have a username and password, which is then the username and password of your storage account, for instance. But the other way to authorize the usage of the API is working with certificates. Every Azure account has its own usage certificate. You have to download that certificate, embed it in your application, so that your application running on your machine can access your management service, of course. Another important attention point is, and this is typical for many cloud scenarios, all the APIs, of nearly all of them, have an asynchronously behavior. This means you're going to ask Azure to do something with your environment, but it will not happen synchronously. It will not happen directly. Microsoft or the Azure environment will give you some kind of ticket, which is kind of ID, and you have to come later, a few seconds later, to check whether the progress is already finished. And it will tell you something like, I'm busy, or I'm at 50%, or I'm almost busy, or I crashed, whatever. Costs are also an attention point. It could be possible that we add some diagnostics to our storage environment, that it will cost you more if you don't do that. Because storing metrics storing metrics about your environment is also inserting records into a table also on the storage account, and that will cost you money. So this is also an attention point that you have to take into account, of course. So let's first look at the management API. Nearly everything you can do on the portal just by clicking and doing something is also possible through REST API. Very simple REST API. For instance, you see an example, delete. You always need to give a subscription ID, and in that case also a cloud service name. So with this API, I will just delete a hosted service called cloud service name in my subscription ID. I need an X509 certificate to do that. It's obvious that you can't simply call that URL and that your service will be disappearing. No, the API or the URL needs to be signed by an X509 certificate that you can download from your Azure management portal. So you get this API or the SDK through NuGet, and simply type in Windows Azure Management.libraries, and it will install everything that you will need. Some libraries, they didn't put it in one library, they decided to put it in many different libraries: management.compute, management.network, management.storage, management.websites. For everything you have a different library. Let me show you a demo on that. So what I will show you in that demo is a very simple way to create a storage account. I'm not going to make it that complicated. So the idea is to create a storage account automated, not by going to the management portal, but do it through code. So I've got all those libraries referenced through the NuGet package. Look at my code. It's simply a very simple program that will create the storage account. Let me put aside this Solution Explorer and the other window. Here is my certificate. My certificate is a very, very long string, and you can get it from the management portal. Well, you just not copy paste it, you will get a file, but if you look at the content of the file, you can reuse that content of the file just as a binary stream in your application. If you just want to use the certificate yourself by pointing it to the file system, that's also possible. But in this solution, I decided, well, let me try if I can create a very small standalone application that really doesn't depend on another file. So I embedded the certificate, hard-coded as a string, into that application. So it's a kind of user and password scenario. So you have this certificate, and you have a subscription ID. You can always find the subscription ID, which is kind of GUID, on your management portal. If you have those two items, then you can talk to the API. Look at this code, storage management client, part of the library, and then do a .create on the storage account collection, and that's it. As I'm creating a storage account, I need to decide on the location, and I need to give it a name. Just as I would do it through the management portal by hand, simply a location and a name. Then I can list it. Let me simply have a way that I can list all the storage accounts. Well, I just iterate through the collection after I've given the correct credential. I iterate to the storage accounts, and it will also give me the keys. So whenever you create a storage account on Azure, you can't decide on the username and password for that storage account. Well, the username is the name of your storage account, but the password is created by Microsoft. And you will get two passwords, a primary key and a secondary key. And the idea is that both keys are the valid keys for the same login, for the same user. But you can revoke them independently. So you can give one key to your customer and keep another key for yourself. So this, well, let me just simply run it. First go to my management portal to see all my storage account to really prove that we create a storage account. Where is storage? I have 11 different storage accounts. Let me create another one through this. The name is Azure Demo Kurt, but I also created this one. So I will add the number 2 in that. Run the application. I hope I've set the correct startup application. We'll simply wait for a key, I guess. No, it is already creating it. And then it will list it again. Sometimes it takes a while. Maybe behind the scenes there is some asynchronously behavior, which is a kind of abstracted from you through that SDK. Let me check my code if I'm not waiting for a key. I already have some program files open. No, it should be there. All right, now it's finished. Let's look at the management portal again, doing a refresh. Already refreshed. I got 12 storage account. Azure Demo Kurt is now another storage account. The list will show me all the keys of all my storage accounts. So you will see the password, so it's obviously that you need a certificate to really achieve that. That's normal. So go back to the slides. let's talk about how to monitor and manage SQL. The SQL database, the SQL Azure database, supports some management views. You do it with a SQL command. We have three categories of dynamic management views. Some of them, of the views, are database related, others are execution related, and some of them are transactions related. You see stuff like sys. And then some dynamic management views. Going to also show you a demo on that. I opened here just the SQL Management Studio connected to a database, which is a SQL database on Azure. First thing we can do is we can ask, for instance, the maximum size in bytes of my database. I want to know how big is my maximum capacity of the database. It will give me the number 1, which is number of gigabytes. And for some reason, Microsoft decides that the number of bytes in a gigabyte is the number you see over there. It's not really 1024 times 1024 or 1024 times 1000. No, it's still different. They have this weird number to calculate bytes into gigabytes. So it says, well, your database is 1 gigabyte in size. What if I want to change it? Then I have to connect back to a master database. Let's create a new query on the master database. And that query is not really a query, it's an altered database statement. And I want to modify it. Let's say I want to make it 5 gigabytes. I'm simply running this command. Command executed successfully has changed my database. Well, not really from a content point of view, but the size has now been increased to 5 gigabytes. So it will give me the number 5. So this is the maximum capacity. This is the moment where your database goes into read-only mode if you reach that capacity. So you want to know how much have I really stored right now? Because this is my maximum capacity. What did I store right now in my database? Well, then we need another query, which is one of those dynamic views, sys.dm.db partition stars, and then we have to divide it by 1024. This will give me the size in megabytes. So I got 12 megabytes into a database of 5 gigabytes. So imagine now you can build an application that will monitor, maybe for instance every day or every hour, the size of your database, really the content size of your database, and compare it to the maximum size, and maybe take some action. Scaling from 1 to 5 gigabytes, for instance. So this is about the size. Let me also show you how to monitor connections. Very simple query. I've got this single connection, which is really my Visual, not my Visual Studio, but the SQL Management Studio. If I would connect from another application, let's go to Visual Studio here and go to Server Explorer and connect again to my database. Modify connection. If I simply click on it, data connection, add connection. Server name is, I'll have to copy paste some stuff. This is the server name. So where is Visual Studio now? Use SQL Server Authentication. Login. Oops, there we go. And if I remember my password correct, and I connect to a database which is Tekorama demo, and I test the connection, it works. I say OK. So now we should see 2 applications connected to my database. So do the query again. It gives me 2 connections. So that's a way to see how many connections do we have. Is it only my web role that is connecting to the database? Is it a developer which is connected to my database? Are there some connections that are still open and can be closed? Well, that's the way to see that. Next step is also to see performance of your queries. I created a very big table here with a stored procedure that adds a lot of records into a demo table. And I also created a view which is based on some other dynamic management views, dmexec and dmexec sequels to text and so on. This gives me the opportunity to, if I select some stuff from a table, which is a really complicated query, let's do a few of them. Yeah. I'll mean with this query here. Yeah. Let's do a few of those queries. Then I can query the BigQuery view, which is based on all those dynamic management views, to see what are the most consuming queries. So it will tell me this SQL statement, select top 200 from demo table and the select star from BigQueries are the most consuming, and you will see the average CPU time. So I ordered my view based on the top average CPU time. And for normal queries, that will be very small in the number of few hundred milliseconds or maybe 10 milliseconds. But for those type of queries where I do a top 200 with a very complicated like statement, you will see, well, it's more than average. So if you monitor that, you can really see, well, where is my most consuming query? Even if you're using Entity Framework that will execute some queries behind the scenes towards your database, that's the way to see where are the bad queries, where are the queries that we're going to lose performance on, and maybe switch from Entity Framework to a stored procedure, or okay, create a custom SQL command. So that's the way you monitor and manage. Right, enough about SQL. No, there is another topic on SQL, sorry about that. How do we back up and restore our database? Yeah. Now there is, but in the old days, there wasn't really a SQL command to do a backup and restore. Because the product was brand new, and there was no way to do backup and restore. Then this API, which is a REST API, not part of a SQL statement, but a REST API that can export, not really backup and restore, but it could do an export to a backpack file. And a backpack file, I don't know if you know it, is a combination of data and the schema. So from that point of view, it's actually comparable to a backup. And you take the database, everything is inside the backpack file. If you export it, all your data there and your complete schema is there. So you can download the backpack file and import it into your local environment, or do the other way around. If you want to upload a database to SQL Azure, where backpack is a very convenient way. You export the backpack from your local environment and you upload it to the cloud, and then you ask the restore API to restore it into an Azure data center, into your SQL server in one of the Azure data centers. You will get a ticket. Very typical asynchronous behavior. It will not happen immediately. You will get a ticket. You have to ask for progress. It's a service, so the API is a service running on some URL, and you will have this MEX endpoint. If you know what MEX means, it will generate WSDL, and you can create proxies based on the MEX endpoint. So it's a kind of WCF environment. So once you have this, add reference to that /MEX URL, the proxies will be created, but then you really have to configure the URL again, because every data center has its own dedicated service location. So one URL could be applicable for the Northern Europe data center, but you will need another one for the Western European data center, or for the US or for Asia. Every data center has its own URLs to do that. Demo. It's not a console application that I've created, but, well, an old-fashioned looking Windows application is this one. Let me put it as a startup project, close the other one first, going back, set as a startup project. Let's first have a look at the code here. I'm going to list all databases, talking to my custom-made SQL Azure Backup Manager, to list all the databases and list all database command will just simply select the name from dbo.sys databases. To have a list of all the databases that I want to backup. Then I want to start a database backup, exporting it to a back file. That will need a database name, and a slot is, well, the slot is something that I've added to this solution. It's just a name. Maybe it's a production environment or a test, a live environment or a testing environment. Give it a timestamp and so on. And then start the database export. And you will need a lot of information for that. The name of the server. You need a SQL Azure data center in which I abstracted away into an enum. You need the username and the password as an administrator to log into your database. You need a database name. But you also need a storage account name and a key and a container and a password for that. Because the export API will simply not give you the backpack. No, it will store it, place it on one of your storage accounts. And then you talk to the API. You need some REST API helper to do that. You define a path to your backpack file, which is living on a blob account, storage account name and storage account key. And then you register the export. Registering the export will add something to a kind of structure, and then that structure is given to that API. Very complex, but let me simply show you the demo, and you will see the asynchronously behavior. So, username and password of my SQL database. I'm going to list all the databases. I'm hitting some breakpoints here, so let's continue. Then I need a storage account with a password and a name of a container, and then start up the database backup. Oops, I have some issues here. Argument out of range. I don't know, I didn't select one. Sorry about that. So it gives me an index of null. So I'll run it again. Let's back up this Tekorama demo database startup. Press F5 to skip the breakpoints. And then I can check the status. Checking the status is again a call to the REST API. He says, well, I'm running. The progress is 0%. Let me check the status again. So again, I'm hitting my breakpoint. I need to do some serialization and deserialization to get that information. And then it says completed. Look at my storage account now. So I've got this tool here to look at storage accounts. Where are you? Oops, you're over here. I've got too many icons at the bottom. So the Cloudberry Explorer for Azure Blob Storage. And then go to my storage account, which was called Azure Demo Kurt. Database backups, which is the name of my container. Tekorama demo. And here is my backpack file. So I created one a couple of hours ago to prepare the demo, and I created one right now. So you talk to the API will put your backpack file on your storage account, and then it's up to you what you want to do with the backpack file. Do you want to import it again, or do you want to download again and import to your SQL environment locally? That's up to you. Be my guest, as Martin would say. So next topic is performance counters, the diagnostics configuration, which is kind of built into Azure. And those are diagnostics based on the operating system. Like you have traditional operating systems where you have pretty much every possible diagnostics configuration that you can monitor. Well, Azure can also do that. And what Azure does is it monitors multiple instances. So you define your configuration once, but all the instances will listen to that configuration. And Azure will take all that metric information from all the instances, because they're different virtual machines, and put it into one table on your storage account. Again, you need a storage account. And after all the metrics are placed on your storage account, then you can use your monitoring tools. That could be third-party monitoring tools or your custom-made monitor tools to see the performance or any other metric. What performance counters do we need? We got a lot of them. You got a few hundred, maybe 1,000 different performance counters that you can use. But on Azure, it's important to understand, while we need to monitor performance counters, that could give us an idea whether we need to scale or not. And the reason why we want to monitor and manage is we want to have scalability. We want to scale out if we're reaching a kind of limit. So we need to look at the boundaries of a machine. What makes a machine full? What makes a machine behaving bad, and that gives us a reason to go for a second machine? Well, first of all, CPU utilization. If it's at 100%, that's not bad, but it's time to add another machine. If you see that CPU utilization is dropping to, let's say, 10%, and you got 5 machines running simultaneously, that doesn't make sense. You have to try to get your CPU utilization, let's say, towards 90%. If it's 100%, then it's over the top. But if it's 80%, 90%, that's good, because then you're utilizing your CPU in a good way. But be careful, just monitor the CPU and act accordingly, scale out or add machines, remove machines. Memory is also a boundary of a machine. So if you select a machine on Azure, you typically say, well, it's a large machine or a medium machine or extra large or a small one. That is defined by memory. So a small has lesser memory than a medium, which is obvious. So the selected instance size is also a limitation because it's limiting your memory. Disk space, you could also monitor disk space, whether my disk is running full, but that's your local disk inside the virtual machine, part of your cloud service. But then again, Azure applications will not typically use local storage. They will use the storage which is outside your virtual machine. If you're architecting in such a way that you're really depending on local storage of your virtual machine, doesn't really make sense. So maybe not important, this space, but you could do that. Also, bandwidth is also a limitation of the virtual machine. It's also limited based on the size of your instance. If you go from small to medium, you double also the bandwidth. And then again, you will also pay more, of course. Okay, let's go for the demo for this. Adding performance counters and downloading the metrics. Again, I've created some code. Performance counters demo. For that, you need to have a deployment ID and the management certificate. So I can simply show the configuration. I'm going to show you a list of performance counters. So I'm using the diagnostics manager. The diagnostics manager is not part of the service management API. It's simply part of Azure itself, of the Azure SDK. So it was there since the beginning. The Azure Management API was born later. And so I have some historical issues here. So you will get an instance diagnostics manager for a certain role. And because you want to change it based on the role, maybe your cloud service has a web role and a worker role, so you want to change it for different types of roles. And then you can simply, iterate through all the performance counters. So the current configuration, you get it from the role instance, and you get the performance counters, data sources, and then you can simply dump to the console and the counter specifier and the sample rate. The sample rate is the frequency that your counters are being measured and put onto the storage. How do you add a performance counter? Well, for that you need a connection string towards your storage account with a deployment ID to really update that file. All the storage account metrics, the configuration of the metrics are simply stored as an XML file on a storage account. And every deployment to a cloud service is coupled to that storage account. And maybe you have seen it, if you deploy from Visual Studio, then you need to select your cloud service, of course, and you want to deploy it to that cloud service. but it also needs a storage account as a way to, first of all, take your package and put it on the storage account, and then move that storage account to Azure to really deploy it. Well, that same storage account that you're using to upload the package will also be used to store the configuration of your diagnostics for your cloud services, and will also be used for storing the metrics themselves. I'm going to show you that also in Cloudberry here, or let me use another tool for that, the Azure Storage Explorer from Neudesic. So I'm connected here to a storage account Azure Demo Kurt, which is the storage account that I used to deploy a package. So you typically have this VS deploy folder. I've seen it during the demo of Martin also. VS deploy. If you go to blobs and go to VS deploy, well, they've hidden it away, or maybe it's already deleted. Normally you should see your package over there. Besides that VS deploy folder, you also have the WAD control container, which contains an XML file. It's going to open that XML file, look at the text, and let me zoom in a little bit. Here you see all the configuration for my monitoring. Memory available megabytes, sample rate in seconds, 180. That's what I mean. Yeah. So you see a lot of different diagnostics part of that configuration. Where are the results stored? So Azure will do that automatically for you. All the results will be stored in tables into that same storage account. For instance, the WAD performance counter table. If I query this table, I will get a lot of records. Each of them with a partition key and a row key. Let's hope it doesn't take that much time. All right, come on. Show me the stuff. All right, right. Almost there. Not responding. Keep on hoping. Cross your fingers. Keep on talking. Yeah, now it is there. Yes, it is there. All right. Huh? So the partition key will contain the web role. You see web role 1 and the instance number of the machine that has generated the metric. You see web role 1, instance 0. And then you will see the metric itself with a timestamp. When did it happen? You will see the deployment ID. And so every time I do a new deployment, there will be another deployment ID. The instance that has generated, well, this is actually a copy of the partition key, or the partition key is a copy of that field. And then you will see the counter value also. So that file, well, it's not really a file, it's an Azure Storage table, will be updated by your configuration. And so Azure will do that based on your configuration. It will continuously add records from different machines into that table. And in the demo, I also show you how to add one, add some configuration, add some metric, and then also dump it again and download, because that information is part of a table. And you can also access tables through code, so you can download all the metrics and store it into your local SQL database. And it's up to you to do that. Some other third-party tools simply do it from the cloud, and they just look at your storage environment, but they really don't download the metrics. But in my idea, it's better to download all the counters and then to delete them from the cloud, because otherwise they cost money. And every time you request them again and again, it's a transaction cost, although our transaction costs are not really that high. But in my opinion, it's better just to download the metrics, delete them from the cloud, and if you want to visualize them or do some querying on your metrics, it's better that you do it on a local database, so to avoid some costs. So let's run this. Let me first show you the code for reading the metrics of the performance counter. You use a storage account table. So simply by asking the storage account, create cloud table client, you get a cloud table client. You get a reference to a table which is called WAD performance counters, and the same table that I've shown you in the Neudesic tool. And then you do a table query. and you specify some filters, and you're actually specifying a query. And you do it through link, but it will result into a REST API query on your table. So here I say, well, for the deployment ID for this role instance, I want to get the information. Not all of them, but simply based on a query. And once I have this, I can also iterate with the for each into the results. It is, again, coupled to a really structured table in my application. So here you see the table structure. So this is public. So Microsoft also created this structure for you to use it. So it's an open structure, and they will not change it. I hope not. So you see the same records, you see the same fields as in the table. And now let's run it. It will simply create an additional. Oops, it's not that one I want to run. Let's go for the performance counter demo. Set as a startup project and run it again. It creates a list of performance counters. It shows you all the performance counters which are in the XML file part of your VS Deploy account. We are adding some additional performance counters, and then we list it again. Now I have 13 performance counters. Press another key. Will take a few seconds to start downloading, but that will simply download that table based on the query that I've given. And once it's got all that information, it will simply dump it on my screen. But imagine, instead of dumping it on the screen, you will put it in your own database and do some analytics on top of that database. Yeah, it will take the same amount of time. Takes me about 10, 15, 20 seconds. I'm not waiting for a key here, but yeah, always annoying in demos that some things take time. But you typically will do that continuously. You will have maybe a dedicated worker role or a kind of schedule that is running locally to continuously read the last metrics from the table and aggregate it into your own database, of course. There they are, all the information that Azure has put into the table based on the diagnostics configuration. So we have seen how to add performance counters, we have seen how to download the metrics. Next possibility to do some monitoring is using the load balancer probe. The load balancer probe is a URL that you will create inside your web application, and you will configure that the Azure data centers or the systems inside the data center will need to call that URL on a frequent basis. Like for instance, every 15 seconds. I think that's the default. Somebody will call that URL on your web application. And that someone is the Azure Data Center itself. And it expects an HTTP 200 OK response. And so you have to generate a good answer. And don't throw an exception or don't generate another HTTP status. No, simply answer to that URL with an HTTP 200 OK. Don't do anything else, or maybe you can check some memory or whatever. But if you answer with the HTTP 200 OK, then the load balancer probe is happy. Then the data center says, well, you're OK. I think you're healthy because you simply responded to me. It's a kind of ping. It's a kind of, are you still alive ping. Yeah? So the load balancer determines which instance can receive traffic by regularly probing each instance in order to determine the health of that instance. What happens if you don't answer with a HTTP 200 OK request? Well, then the load balancer will simply put you out of the cycle. The machine will not be rebooted, nothing will happen with the machine, but the load balancer will decide, well, since I didn't receive a correct HTTP 200 since the last 15 seconds from that machine, I think that machine is in trouble. That machine will keep on running, that's for sure, but the load balancer will not issue any or not forward any requests from the internet to that machine. Of course. That's the idea. It will keep asking every 15 seconds, are you okay? And at the moment you answer again with a 200 okay, and it's up to you to decide that, then the load balancer will say, well, he's happy again, he's healthy again. Let's throw him also some requests. Until another machine answers with another error message, not 200 but something else, and then it will shift to another machine. So the machine will not reboot at all, but it's a way for you to decide, well, I'm feeling unhealthy, I need to do something, I will do something about it, and after a while I will respond back that I'm back alive. So one scenario could be that, well, you have some machine that is running at 80% of the utilization, and you know, well, I need some more margin, I want to have a 30% extra of CPU utilization. Well, if I'm reaching 80%, I will respond with an error message until the requests are all finished in my machine and I'm dropping again to 70 or 60%. Then again, I will answer the load balancer probe request with the correct answer 200, and then I'm getting the requests again. So it's a kind of load balancing inside load balancing. It's a kind of way to put the machine temporarily on hold, to say, well, I'm not doing very good, and don't invite me. I'm just sleeping for a while, and after a while, come back to me when I decide. And that's the thing about the load balancer probe. Logging? No. It will simply say, well, if I'm not getting a 200 okay back from you, I decide that you're not healthy, and I will not forward any requests, but it will not do any logging. It is just a way to say, well, stop the traffic for a few minutes, and then give me back the traffic that I missed, something like that. Here you see how to configure the load balancer probe. It's part of your service definition. It's not part of your service configuration, mind. There are two options, there are two levels of configuration for an Azure Cloud Service. You have the service definition, which not really can be changed without redeploying your service. And you have the service configuration, which has more dynamic name value pairs for your app settings. This is part of the service definition. So it's really kind of hard-coded into your deployment. So you define, well, mycloudapplication.net has this URL, could be a simple ASPX file. Also give it a port number, give it an interval in seconds, a timeout in seconds, and then the load balancer will try to ping you every interval, and you have to respond within a reasonable timeout. You can specify the timeout yourself with a 200 OK answer, and so on. Okay, Azure Storage Analytics. This can be configured in the management portal. Blobs, tables, and queues. You can get a kind of audit trail on top of that. And so that's logging on top of your cloud, on top of your storage account for auditing purposes. You have two levels, minimal and verbose, and you can also specify the retention day, because logging about your storage account kind of doubles your storage account in size, so it will cost you more money. So you have to be careful about the retention days. Do you really want to keep that audit and that logging for months? No, maybe for a couple of days, nothing more than that. You can log your read request, you can log your write request, you can log delete requests. So it's really an audit trail on everything that is happening with your storage account. On a lower level, you can have counts on querying tables, on querying entities, on getting the service properties, and so on. A very detailed way of working. So how do we monitor queues to scale the number of worker roles? That's another topic. Don't confuse. I'm talking again about another topic here. That's a project I've done for some customers, where they wanted to have a kind of alerting system when a queuing system was having too much messages into the queue for some time. And they wanted to have an alert with SMS and with an email and have a kind of dashboard to really see whether too much elements were stuck into the queue. So the idea is to use the cloud queue.approximate message count property. So you're using cloud queues to insert messages into a queue. You're using the cloud queue API to read messages from the queue. Well, the good thing is the approximate message count will give you the number of messages from a queue without reading any message. So you won't change the number of messages, you won't add and you won't delete one, but you will simply get how many are there in that particular queue. Okay. The code for that is looking like this. Again, you create a cloud storage account with an account name and a key. You create a queue client from the API, you get a reference to the queue, and then very important, you have to do the fetch attribute call. And if you don't do a fetch attribute call, the message count will be 0. If you do a fetch attribute, then the approximate message count will be filled up with the correct values. That's important. I'm going to show you a demo on that. Yes, let's add this one, add the Azure Queue Monitor, set it as a startup project. Simply run it and then we will have a small look at the code here. So this one will simply load up all my queues, just list all the queues into my storage account. I created 2 queues, so I have dummy queue 1 and dummy queue 2. You can also see them in the new Desic tool. Let's go to that tool again. Where are you? Too many icons here. So if I look at the queues, you got this 2 simple queues. Here we got a couple of messages, and into that other queue, there are also a couple of messages. And now my application will start monitoring them, and it will see, well, dummy queue 1 has 5 messages and dummy queue 2 has 10 messages. Let pop one out of the queuing system here. Pop it. It will be permanently deleted, yes. Let's pop another one from another queue, pop. Yes. So I'm reading. It's like my work role is reading the queues. So it has changed from 5 to 9. So I also show that in the list box over here. The dummy queue 2 has changed from 10 to 9. I don't know, it's not monitoring the other queue. But now let's read them all. I have this simple message, a simple button here to read all the messages from the queue. Again, it's happening asynchronously, and then you will see, well, both of my queues are empty. And if I do a refresh over here, you see that all the messages are empty. So maybe some code, while you will see the approximate message count over here. Oops, I didn't catch any errors over here, just demo code. So I've got this start monitoring method over here, which will get the number of messages from a queue. I have a queue monitoring manager, and here you see the fetch attributes, and then I will return the approximate message count. And so I created a little application on top of that that will keep all the messages, well, not the messages, but the number of messages into an array and then show it on the screen. And if I see some changes, then I will react to it by updating my screen that the number of messages has changed. But think of it as a more, think of it in a broader way. That's the basis of your scaling engine. And you can create additional queues based on that principle, or you can add multiple machines. You can add a machine to the load balancer, and so on. So that was everything about APIs. We have seen different APIs, REST APIs, SDK APIs, SQL APIs for many different purposes, for your database, for your performance counters, for your queues, and so on. Also have a small look at the deployment options that we could have. We can publish from Visual Studio, which we typically do as a developer. Well, let's publish to the cloud, and we say, well, Solution Explorer, right-click, publish. That's not really continuous integration, because we're doing it ourselves as a single developer. We're deploying something, but we don't have any continuity. We don't have any integration. Another option to really deploy stuff is use the cspack.exe. And that's a tool, part of the Azure SDK prompt. And that tool can create a package based on your solution. So you point it to your SLN file or to your binaries directory. And then you can upload that package to storage and call the service management API, like the one I've shown you, to create a storage account to deploy the package. So you have some custom tools, you build your own custom tools to do that. And then you can use those deployment mechanisms based on CSPAC, based on the APIs, and put them into your TFS. In your build script, in your post build, when you have a green build, then you will deploy a new version, or you will import a new version of the database, and so on. So you can really have some nice scenarios based on all the stuff that I've shown you here. If you do it yourself, custom deployment mechanisms that can be called from Team Foundation Server. But let's look at another option, visualstudio.com as a source repository. I don't know how many of you are using that. Maybe you're all using TFS locally, but you know there is also a version of TFS really as a service in the cloud, with also build environment. Who is using that? Only a couple of them, yeah. And what happens is, Azure will do a deploy after your check-in has happened. Let me show you that in the demo. So I'm going to my visualstudio.com environment, where I created a project which is called Tekorama Demo 1. I have the source over here. So I did some check-ins already. Here is my solution, so all my code is there. It's a very simple web role, which has a view directory with a home controller, home view, and an account view, and so on. So this is my source control. Let me open Visual Studio where I can change that. So in this solution here, this is the solution that is connected to that environment. First wait for preparing, so it will connect to TFS, and I can do a check-in. So here, don't you love Azure, which is part of the HTML of my index view. Let's say for sure, oops, typo, and then do a check-in. So the index file of this one, sorry about that, is ready to check in. So let's check it in. Give some comments, check it in. Do you want to check it in? Of course I want. So it's checked in into visualstudio.com. Let me see if I have the new version over here. The index of home. Downloading the file, and it has changed. Okay. What happens now is an automatically build has been started. Maybe not immediately, but after a few seconds or minutes, you will see a new build. Because I've done a check-in and I've added a continuous integration option. Let me look at the queue builds. This is the build that I've already completed. So there is another one queued less than a minute ago. Azure Demo Cure 2 has been queued with an ID of 27. Once this is built and there are no errors and everything is correct, it will be deployed to my Azure cloud service. But to achieve that, of course, my cloud service needs to know about my storage, about my Visual Studio environment. So whenever I create a new cloud service, let's create another one. Let's say Azure Demo Cure 3. So simply creating a new cloud service account. Not that one, but the one that is created here. Where are you now? Oops, just waiting for a refresh. I don't see it. Did I just create a cloud service or what? Other here, maybe I could not be created. Why? What the hell happens? Haha, okay. I'm doing too much demos and proof of concept and stuff like that. So with the basic account, you can only create 20 hosted services. So I already have 20. So yeah, but don't worry. Let's go to the one over here. And yeah, let's disconnect from Visual Studio again. And I will do the scenario again. So you see how it works. So I'm disconnecting from Visual Studio, and now I'm doing the publishing with Visual Studio lane again. So I have to specify the URL of my visualstudio.com account. Of course, I need to authorize. So now he's asking me for, do you really want to add your source code or your completed build into Azure? And we have to have some handshake to do that. You have to authorize as an owner of your visualstudio.com account, as an owner of your source code, of course. You have to accept that the application, which is called Managed Prod Cloud App from Windows Azure, is requesting the permission. So let's accept that. And if it's accepted, it will list all the repositories that you have. So again, I played around a lot, so a large amount of repository names. Let's check the Tekorama demo 1 and click OK. It will do the linking the team project. The page will refresh soon. Whoops, I only have about a couple of minutes. Yeah, thanks. So yeah, it's already deploying. You see individual continuous integrations, the Azure demo Kurt 2, and then some date, 5 minutes before 9 o'clock today. He's doing the deploying, because the Visual.com environment did the build after I've checked in my changes to the code. I connected my service to visualstudio.com and selected the correct repository, and it will start to do the deploy. But just mind, it's only deploying into the staging URL. And so in Azure, you always have a production environment and a staging environment. The production environment is your really cloud app.url, but the staging environment is just a GUID.cloudapp.net, and you really can't select GUID yourself. Right? It's just a temporary cloud service. But whenever you connect the cloud service with your TFS, with your visualstudio.com, it will only deploy from your build source code towards the staging environment and not to the production environment, of course. So this is what is happening right now. I can see a log file, and once this is finished, it will be live, of course, but not really live. It will be live on the staging. So deploying could take a couple of minutes here, and it will do an in-place upgrade. So your old service will not be down. It will simply make sure that there is no downtime. Even if you're running in staging, you have that assurance that it's not going down your machine. It will do a rolling upgrade in place. So okay, let it deploy, and maybe later we will see. So those are the deploy options that we have from Microsoft. Working with Visual Studio, having the CS pack, building some custom mechanisms based on the API, or having Visual Studio as a source repository. But what about this? This is my idea to have a completely custom deployment mechanism. Martin already talked about the web deploy, or the web deploy that you could do from point of view of from development. I took this idea a little bit further, and I also made it persistent. And I also use that way to deploy with one of my customers. And the approach, I call this the Azure Publish the Package approach. So from within TFS, when the binaries are built, and we have a green build, and the binaries are dropped into a drop folder, what I do is upload those myself to storage. Well, not really by hand, but with some command line tool that is integrated into the build script, command line tool that I've created myself. That will take all the binaries, put the binaries into a zip file. So I'm completely abstracting away from the CS pack and from the package solution that Microsoft is trying to do. So I'm just taking the approach that the binaries are coming from my TFS. I don't care about the package, but what I do is I have this empty, completely empty Azure instance with IIS running, but that Azure instance really doesn't run my binaries. I want to put my binaries into that machine, not in my package, but I want to put the binaries from within TFS into that machine. So what you need on the Azure instance is a kind of bootstrapper, completely customized. So the only application that the Azure machine runs is a bootstrapper, not my real application, but the bootstrapper, which is WCF service. And I can talk from my local environment to that WCF service to tell, well, there is a new version on storage of all the binaries, each part of a zip file. You have to download that, so the bootstrapper will do that for me, based on a trigger, based on a call that I sent to the bootstrapper. And then that bootstrapper will take all the binaries from the storage account and put it underneath the IIS. And the machine will not reboot. I don't have to redeploy or reboot the machine at all. No, I simply talk to my bootstrap, and the bootstrapper will do everything. Then the next question is, well, is this persistent? It's the same way that you work with the web deploys technology. Well, I made it persistent in such a way that the bootstrapper is also called during the startup event of each machine. So I have some kind of configuration file, custom-made configuration file that tells and that explains to the bootstrapper, those are the binaries you have to take into your machine. That version, it's sitting on that storage account, and you can reach it with those credentials. So whenever the machine reboots, whether I reboot the machine myself or simply it has crashed and Microsoft decides to put another machine in place, or there is some maintenance into the data center, the Azure instance reboots, but the custom bootstrapper is also capable of getting the new binaries from the storage account based on a configuration file and also putting it into IIS. So I can reach the two scenarios. One scenario is where the developer really wants to quickly deploy a new version to test it. And the other scenario is to make it persistent, to make sure that every time the machine reboots, also the new binaries are uploaded into the web server. But I completely abstract away from the CS pack, from the package definition that Visual Studio is using. And it works. It takes some time to get that up and running. There are some issues that you have to take care of, like load balancing and having multiple machines, and you have to do a master election to select one single machine. Some nasty issues, but it's a good approach. And for some scenarios, it's really better than compared to what Visual Studio or the classic upload scenario would offer you. So have a look at it, think about it. It's really a good option. So we have seen continuous integration with visualstudio.com, and that was about it, about my talk.